Hello friends, you are watching ERUDIRE Plus, the professional CAD/CAM solution provider. This channel provides basics of finite element analysis and computer-aided mechanical engineering design and analysis using CAD-related software. Let's get started.
This is an axis symmetric problem and we'll convert this 3D problem as a 2D. Reynolds number will be less than 2000 and the flow is laminar flow. Okay. Then let's get started using ANSYS Fluent. We're starting from fluid flow. Default name of this project we can provide as CFD cylindrical surface. Next, the geometry property should be checked. And from there, we'll convert the 3D problem to 2D one. Let's convert 3D problem to 2D. Next one, from the geometry, we have to start our new design model. This is the design modeler. We have to start drawing from XY plane. And let's take the normal view, starting from sketching and rectangles. As I told already that we are considering this problem as a 2D one. Since it is an axis symmetric problem, we'll convert this one as a 2D problem. So we start from the axis only. Okay. We have drawn the rectangle. Then we have to provide the cylindrical surface near the axis. So we'll take a circle. We can trim out unnecessary portion. So from modify, we can trim. Now let's provide dimension to this one. Length h1, height v2, the radius equal to r4. Now let's provide the actual dimensions. h1 equals to, let's take equal to 100 millimeter. h3 will be 50 millimeter. v2 25 millimeter. And the radius will be 10 millimeter. Let's provide h3 equal to 40 millimeter. Done. The dimensions have been provided properly. Next one, we have to make this sketch as an area. First of all, let's generate the sketch. Then concept, surface from sketches. Select any edge, apply, then that to be generated. Our surface is ready. Next one, the surface property you have to check. Select the surface body and the surface should be having fluid body. That is required for meshing purpose. Okay. So our model is complete. We can generate and we can proceed for the next step. Okay, let's close it. Next one, we have to provide mesh. Edit mesh. Now this is our model that we meshed right now. Okay. Before providing meshing, we can do one thing. We can provide specific names for the inlets, outlets, and the boundaries. That is actually required for boundary conditions. Okay, let's select the edges. This is entry. Actually, you can provide the name of this one as entry. This one will be exit, this one will be boundary or walls, this is wall, okay, and this one by control select the other edge of the axis also. I've selected both the edges of the axis and name it to axis name provided. Now we have to provide the cylindrical portion. As it is a 2D model, so this semicircular part is actually the semi-cylindrical part, right? Okay, we'll select that one, provide the name as cylindrical portion, done. Now let's check the namings. Entry, exit, wall, axis and cylindrical portions all have been provided, right? Next to that we can provide default mesh. Default mesh is being generated, it is done. Now we have to update this one, that to be refined. For refining the mesh, the default meshing we can do face meshing. Select the surface, apply, then update. Face meshing is going on. Let's check that. It's little bit modified. Still it is not updated, we have to modify it. Okay, how to check the mesh quality? We can check it from the statistics itself first. The numbers of elements is 105, it is very less. We should have the numbers of elements from the range of 4000 to 40,000. Numbers of elements to be increased here. Okay, done. We have to select the edges where we have to provide specific sizes of elements. Let's take the wall first. It's selected. Now next one we can do number of divisions of this one. We can provide 1000 divisions. And the behavior of mesh should be hard. We want the mesh quality to be hard, as we don't want any kind of interference of this mesh with the software. Hard mesh means it will not be modified. Next one again, mesh, insert, sizing, select the location, apply. Now the number of divisions we want at this location, number of division equal to 100 divisions, and the behavior of mesh should be hard. Now the last one, we have to size the entry and exit. So starting from mesh, insert, sizing, we have to select the entry and exit, apply, and the number of divisions we want 100. And the behavior of mesh we want to be hard. It is done. Now we can go for refinement. We can go for update. The quality of the mesh, you have to check it. First of all, we check from the statistics. Numbers of elements is equal to 9668. It is good enough because we want minimum 4000 numbers of elements. It is okay. Now we have to check the qualities of this mesh. It can be checked from display type and aspect ratio. It appears to be okay. Let's select some other things. Skewness. Actually, skewness at the boundary should be avoided. It is okay. We have provided refinement at the boundary, so we don't have any problem at the boundary. And let's check orthogonality also. Orthogonal quality. It is good enough because orthogonal quality should be maximum 1. If it is 0, it is very bad. It is in the range of 0.5 to 0.99. So it is good orthogonal condition. Now another thing you can check is quality of the mesh. Element quality you can check. It is okay, not so good. It is in the range of 0.28 to 0.99. If you want further change, then we can change the pattern. Like we can do something like from sizing. If we want to change this one from curvature, we can make it to adaptive meshing. We can go for adaptive meshing. And update. It is input. Let's check the statistics. Numbers of elements have been increased from 9000 to 15527. It is very good one. And even you can see at the circular portion, it is fine refinement is done. Okay. Even at the boundary also we can find better refinement. Okay, let's see the other things. Now let's see the aspect ratio and element quality. Aspect ratio, it is okay. And also we can check the orthogonality. It is 0.44 to 0.93. Okay, now the mesh quality is good one. Okay, now we can go to the next step. Let's update this part and go to the next stage. To start with setup. It is a 2D problem and we are going for double precision. Okay, now first of all we'll check the geometry. We'll check the geometry is okay or not. It's done. It is providing different areas, volume, surface area, etc. Then we'll see the mesh quality. It's done. Aspect ratio is 6.1. It is an axis symmetric problem. Instead of planar, we have to shift to axis symmetric one. Next one, let's see the model. We have already told that flow is viscous laminar. Next one, we have to select the material. Water will be flowing through the entry. From Fluent database, we have to select water. So water liquid we have selected. Next one, cell zone, that means our fluid domain is required to be defined. It will be water liquid. Okay. Next one, we have to provide the boundary conditions. From the entry, we are providing water with an inlet velocity of 0.05 meter per second. So velocity inlet we are providing 0.05 meter per second, and exit, that will be atmospheric pressure. At the exit end we want atmospheric pressure should be there. Done, and everything is finished. Now we can go for solution methods. We are taking default as simple method, and to provide better accuracy you can go for residuals to be in the range of 10 to the minus 6. Okay, now let's initiate our problem. We want standard initialization, and it will start computation from the entry. Let's initialize and run calculations. So numbers of iterations we are considering 1000 numbers of iterations, and let's calculate. Calculations are completed. Okay, we're going to see our results from graphics. Let's select the contours, and we want to field, and we want to see velocity distribution. Save and display. You can see the velocity distribution. That means velocity is not changing that much. Little bit of a deviation from this cylindrical surface. You can see the deviation through the cylindrical surface and velocity distribution. Let's see pressure distribution. Pressure also that much of change is not there. Next we can do one thing, we can see the results from plots, XY plots. We want to see the distribution of velocity along the axis. So from here we'll select velocity, and when we say axis, let's plot. So it is clearly understood that initially at the entry velocity was very high. It was 5 into 10 to the minus 2 meter per second, as I told, 0.05 meter per second. Then as it was approaching towards the cylindrical surface, its velocity reduced. Then again after passing over the cylindrical surface, its velocity increased. Okay, this is the behavior of fluid along the axis, right? Okay, next one we can do one thing, we can compute some results from reports. Surface integrals, you receive facet average and velocity. Now at any location you can find velocity, pressure, etc. Suppose you want to find velocity at the exit, because entry velocity you know. Let's check the exit velocity. We can find out exit velocity equal to 0.047 meter per second. Now suppose you want to have a difference in inlet velocity and exit velocity we want, so you can select entry velocity also, compute. It will show the net velocity equal to is the difference between entry velocity and exit velocity. It is equal to 0.048 meter per second. Similarly, you can see pressure also at any location. Okay, let's see the difference of pressure between the entry and exit level. Entry level pressure equal to 0.33 megapascal and exit level it is 0. Let's close it. For detailed visualization of our results, we will move to the next stage. Let's close it. Now we want to see results. This is our model. We want to see in the XY plane. Okay. Now first of all we want to see that contour. Name of the contour as contour 1, and from the default legend view you want to see velocity distribution. Okay, location it will be periodic show, and we want to see velocity. Let's apply. It is showing velocity distribution. What we saw before, it is exactly same like that. Now this is one only segmented part. If you want to see the whole part, then we have to make a mirror of this view. So what we'll do is apply reflecting mirroring. This is XY plane. We have to make a plane XZ plane, and with respect to XZ plane we have to make a mirror of this one, right? So with respect to XZ plane we want to make this one to be mirrored. Is done. Now what we'll do is the contour 1 we want to make duplicate view of the contour 1, that is named as contour 2. Select contour 2 and that to be mirrored again at this location. Apply mirroring. Done. So this is the velocity distribution for the whole body, right? We can uncheck this wireframe. So this is the actual view of flow over the cylindrical surface, right? This is the cylindrical surface. Water is flowing through along this direction. Okay. Next one, we want to see these vectors. So we have to remove these things, contour and contour 1 and contour 2 to be removed. Let's select the wireframe again. Next one, we want to see our vectors. As vector 1, the location will be same as before, periodic show, and we want to see velocity distribution. Let's apply. This is the vector velocity distribution. Okay, like before also we can see this one as a complete view. So for that view, apply reflection with respect to XZ plane, apply. Now vector 1 to be duplicated by the name of vector 2, that to be mirrored again along ZX plane. Done. Uncheck the wireframe. This is the velocity distribution in the form of vectors. Similarly, you can see a pressure distribution also. Okay, let's uncheck these things. Vector 1 or vector 2, we uncheck it. Finally, we want to see the flow trajectories, how the water particles will be moving throughout this passage. How water particles will be moving, we want to see in the form of streamlines. Okay, default name is streamline 1. And again we want to see velocity. It will be starting from entry. Let's apply. It is the velocity trajectory. Like if we want to see the complete passage of this trajectory, so view, apply reflecting mirroring with respect to XZ plane, apply. Then streamline 1 to be made a duplicate by the name of streamline 2. Select streamline 2 and that to be mirrored again with respect to ZX plane, apply. Done. Let's uncheck the wireframe. This is the flow trajectory. Now suppose along this path we want to see the movement of water particles. That can be checked in the form of animation. Let's see the animation of water particles along this flow trajectory. Select both the streamline and we want to reduce the speed, and also let's make this one to be repeated 2 times. Let's start it. It is showing that all the water particles are moving approximately equal velocities. Only some particles which are passing toward the central axis is deviated by the cylindrical part and it is having less velocity. Okay. Now we can do one thing. We can increase the size of these spherical particles. Some options are there. Size number we want to increase. Instead of 1 we can make it suppose 2, and instead of ball we want to make this one 3D fish, and spacing we want to increase to suppose 0.8, and we want to see this background to be white. Okay, this is for actually saving option. We are keeping the background to be white for saving option. Okay, let's select the path and see. Let's save this part. can save it. In the desktop we want to save it. Saving is going on. This is all about our today's analysis. It was a fluid flow over a cylindrical surface using ANSYS Fluent. If you like this video, please subscribe and share. And if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again. Bye.